Hello and welcome. This video will be made available on Brightspace. So in case I go fast during the video for the purpose of class, you'll be able to watch this again later. The slides are also on Brightspace, so you can follow along on your computer at home as well. We just took a test over Unit 1 on voting, and that will be the end of voting for the entire semester up until the final exam. In the final exam, we will see all 4 units again. It will be cumulative. So for the moment, though, we're going to move on to Unit 2, which is on fair division. And what fair division means is exactly what it sounds like. We want to divide something up fairly. So to start with a rather silly example, let's imagine it is Halloween. We've got 3 kids knocking on our door, and we've got 15 pieces of candy left. We want to get rid of it all. How do we divide the candy fairly among the kids, assuming that each of the kids deserves the same amount of candy? Well, this is pretty easy. We'll just take our 15 pieces, divide them up among the 3 kids, and we'll give out 5 pieces per kid. That's relatively straightforward. We've divided it up fairly in the sense that each kid got the same amount. However, we could imagine a slightly different scenario where we have 17 pieces of candy. And now those 3 kids knocking on our door, we have to divide up those 17 pieces of candy amongst those 3 kids. This is slightly harder because 17 is not divisible by 3. So if we try to plug that into a calculator, 17 divided by 3 would be, 5.666 forever. And it would be hard to give out that, 0.6 piece of candy unless we're willing to break the candy apart and give chunks of candy. This is just going to be a messy situation. There are a few different ways, few different approaches that we could take. We could give each of the kids 5 pieces of candy, and then we just have 2 left over. So then the question is, what do we do with those 2? We could try to keep those 2 extra for ourselves. If we don't want them, if we have to get rid of them, we could give 2 of the kids 6 and 1 5. So we just split those 2 extra. We just have to give them to someone. And that would mean that everyone gets as close to 5 as possible. We could give 1 kid 7 and then the other 2 5. And again, that's trying to make it as fair as possible, but now it really does seem like one is a lot more than the others. Or we could just keep them all ourselves, but that feels like it defeats the purpose. So when we're talking about dividing things up, there are 2 different kinds of objects that we might be trying to divide up. So the 2 main vocab terms for this video are discrete objects and continuous objects. When we're talking about trying to divide up candy and we see that, oh, we actually have 5.6 pieces of candy that we should be giving out, but it's kind of awkward to talk about 0.6 pieces of candy. This is because pieces of candy are discrete. The term discrete refers to whole objects, things that can't be infinitely divided. So for instance, we'll be talking about apportioning members of Congress. So Montana, for instance, has 2 senators and 2 representatives. Wyoming has 2 senators and only 1 representative. California has over 50 representatives and 2 senators. You'll never hear us talking about 1.5 senators or 3.14 representatives. Humans are things that can't be infinitely divided. Talking about a half of a human is kind of weird and maybe a bit gross. But things like how many classes you're taking, how many computers there are in the room, these are things that we can count, but these are things that cannot be infinitely divided. So if I'm trying to apportion representatives to different states, if I'm trying to figure out how to divide up classes into different classrooms, I'm probably not going to be referring to halves of these things or decimals. These are whole numbers. Whereas a different sort of thing that we could divide might be a continuous thing. So things that can be infinitely divided. So for instance, land. For instance, if you were going to buy some property, you wouldn't say that you're going to buy one land or maybe 4 land. You would measure it. You tell me how many acres of land you have. If you need to divide up your time amongst your chores or different classes for your homework, you're not going to say I'm going to allocate 2 time to this class. No, it would be 30 minutes, an hour. You would measure that out. These are sorts of things that you don't count. You would measure how much you have. And there can be a little bit of gray area. So for instance, money, if I'm talking about money, is money something that comes in whole objects that can't be divided up? Or is money something that is continuous that I could divide up however I want? And the answer is, it depends. For money, we could think about money as being, say, dollar bills. If I needed to split a dollar bill and I need to give 50 cents to one person, 50 cents to another, I can't cut the dollar bill in half. Money doesn't work like that. I can't melt down quarters and redistribute them. Coins, bills, they can't be divided any further. They're physical objects. Cutting them in half doesn't work in the way that we might expect. It ruins the money. So in this case, physical money is discrete. However, in a bank account is essentially just a number, and banks can and often do sort of go into decimals of money. So in a bank account, you could potentially have say $1 that you could split into 50 cents and 50 cents. You could go even further. You can even split cents. If you've ever visited a gas station, I imagine many of you have, if you look at the price of gas, quite often there will be an extra 9 at the end. So instead of the price of gas being, say, $3.29, it'll be $3.29 and 9/10 of a cent. So money is something, as an abstract quantity, as a value of an object, we can divide up more than just cents. We could infinitely divide that. So physical money is discrete. We can't divide that up. But money as a number in a bank account, as an abstract quantity, we could divide up however we want. Food is also something that could be discrete or it could be continuous. If I'm talking about hamburgers, I'm going to be talking about 1 hamburger, 2 hamburgers, 3 hamburgers. I'm not ever going to mention, say, 7.68 hamburgers. That doesn't really make sense depending on the context. Things like hamburgers are quite often going to be discrete. But if I'm talking about spaghetti, I would probably not say I would want 1 spaghetti or I want 5 spaghetti. I'm going to tell you amount. I want 1 bowl full. I would like to order, say, 1 pound of spaghetti to split up. Spaghetti would be something that you would measure. So depending on the food, it might either be discrete individual objects or it might be more of a continuous thing. On the quiz next week, I will ask a question that is going to list some things, and I want you to tell me if they are discrete or continuous. This is very subjective. So in each of your answers, you will have to defend your answer. If I ask for something like farmers, for instance, you should think, oh, farmers are human beings, and we don't divide up human beings. We don't chop up human beings. Those are discrete objects. Whereas if I'm talking about farmland, well, it's land that we can divide that up however we want. So that would be continuous. But what I'm looking for is your explanation, not necessarily just the discrete versus continuous. The other scenario that we want to think about is when we're dividing something up, we could be dividing something up between equal parties where everyone deserves an equal share, where everyone deserves the same amount. So for instance, when someone comes into an auction, one person's money is just as good as another person. When you're dividing something up among friends, you're say like cake or some pizza, you're probably not going to go, well, this person is going to get 2 pieces and this person is only going to get one. Everyone will get the same amount um, to start with, but maybe some people are less hungry than others. Unequal parties, there are situations where some parties will deserve more than others. So for instance, when you're allocating resources, I can give a good example, say for school districts. When school districts are when the state will allocate money to each school district. A school district that teaches 2,000 students is probably going to need more money to be able to teach those students than a school district with only 10 students. So we have to keep in mind what is the need for various things. And so when I talk about people deserving more or less, this is one example. Say when you're allocating resources based on need, some parties' needs will be greater than others. And then the example that we're going to be talking the most about, which is what I'll be talking about in the next video, is apportioning seats in Congress. According to the Constitution, the number of representatives that each state gets is going to be proportional to their state population. So a state like Montana, which has fewer people living in it than, say, California, will have fewer representatives. And so next week and in the other video today, we'll be focusing on exactly how we go through that calculation.